today we're talking about recursive sequences. But before we start, recursive is kind of exactly how it sounds. We're going to talk about how to generate sequences using a recursive sequence, so taking the previous term and figuring out what to do to the next term. So we kind of talked about this the first day of sequences. If I have a sequence A, and I'm saying, okay, here are my terms in the sequence, right? I have A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6, okay? So if I just, list 3, 6, 9, 12, 15, 18, so say this is my sequence, right? If I want to know any term in the sequence, we'll call this term A. If I want to know A of n, how do I find A of n from the term before it? Well, I have to take the term before it, which is A sub n minus 1, kind of like we talked about, and I have to add 3 to that term, and then I will get this term. So the recursive formulas are kind of like looking at the term backwards. So the only tricky part about this is the notation. So this is the term before, this would be the term 2 terms before, and I could keep going back n minus 3 and minus 4. The opposite way, if I want to go other way, I could do n plus 1, A sub n plus 2, A sub n plus 3. So like I said, these are really the tricky terms. So we've worked a little bit with the notation, but we're going to really work with it today. Okay. So if you look at this first example here, it says start with the number 4 to generate the next term, and the term that follows, add 5 to twice the term before. So if I take twice of the term before, that's 8, and then I have to add 5 to it. 8 plus 5 is 13. So that's my next term. Then I do the same thing to get to my other term. I say, okay, I have to take this times 2, add 5, which gets me 31. Okay, and if I keep going, so I have to times it 2, add by 5, I get 67, and then 139. Okay, so I just generated that sequence just by knowing how to get from one term to the next. Okay, so if you look at this one, try this one on your own. It says to generate the next term, find 4 less than the square of the previous term. So I'm going to take the square of the previous term, that means square it, so negative 3 squared. And then 4 less than that, I have to subtract 4. So technically I'm doing 9 minus 4, that's going to give me 5. And then I do the same thing. I do 5 squared minus 4, that's going to give me 21. All right, and then I got 436, and then I got 1,000. I get a big number here. I think this is 991 or 091. Okay. All right, so then it says the formula for recursive sequence involves 2 components. It involves the starting value A1, so this is the first term in the sequence, and the formula AN to generate all of the other terms. So like I said, if I picked a random term like this one and called it A sub n, I have to know the term before this. So this notation is going to come up a lot in these formulas. So it says use the examples from above. We would write. So this wants me to generate the sequences, okay? And if you notice, I'm saying, all right, if I have A sub n, I have to take the term before it. I have to multiply it by 2 and add 5. So that's what we did in the first sequence up here. Okay. This one gave us a starting value of negative 3. If I want to find the next term, I have to take the term before it, which is in the parentheses. I have to square it. So I have to square it and then subtract it by 4 to get the next term. And that will generate the rest of the terms. So like I said, the notation part is the most important. So if you flip the page, all right, if you see, this is the term we want. And this is the term before it. So you're really looking for the A sub n minus 1. That just means the term before. Okay, so it says my first term is A1, is 8. So I can fill that in. This says to take the previous term, to multiply it by -3 and add 10. So I can do -3 is 8 plus 10. So that's a -24 plus 10 is a -14. And then I can do the same thing for this term. So I can take -3 times -14 plus 10. That's going to give me positive 52. And I can keep going, and I'll get the next terms. Notice that I can only find the term after. I have to know the term before. So I can't find a random term. Like, I can't find this term without knowing the one before it. So recursive really makes you have to know the term before it. And the other ones we did, like the arithmetic sequences that we did before, those you didn't need to know the term before it. You could find any term in the sequence because you could plug in a sub n. Okay? If you actually plug in the number, so say I want to find a sub 8, okay? Then I'm plugging in 8 wherever I see n, just kind of like we talked about. So I would need a sub 8 minus 1 plus 10. Notice if I simplify this, I get -3a7 plus 10. That means I need the 7th term in order to find the 8th term. Okay, so that's how the formula kind of works if you're actually substituting in. But like I said, you cannot find any term in the sequence with the recursive formula. You can only find the one next to it, the one next. Okay, so your job in class is to finish this and then your homework, and then we will go over some stuff tomorrow, and then you'll do your graded assignment in class tomorrow. Thanks for watching.